Okay, welcome back. This is add, subtract, unlike fractions, page 292. So a couple things you're going to need. You're going to need your book. You're going to need a notebook, something to take notes in. You're going to need something to write with. Okay, you might need highlighters, you might need markers, you might need pens, pencils. Get those together. Unpause it when you have all those together. Unpause it when you're turned to page 292 in the book. You're going to need a title. So make sure that there is a title on your notes. Add and subtract unlike fractions. Okay, today's essential question: what happens when you add, subtract, multiply, and divide fractions? We are still talking about adding and subtracting fractions. But today we are talking about unlike fractions, which basically means we're going to be talking about those unlike denominators. Okay? So, let's go ahead, and if you notice, I put some of the useful stuff that's from the book onto the notes, and then I do kind of have my way of doing the adding and subtraction of fractions, and so that's probably going to be a little bit different than the notes. And then from that point you pick and choose. Maybe one method is better than the other, because today there's going to be more than one method to add or subtract, and usually one method is the way you would do it in your head, versus the other method is the way you would do it on a piece of paper. So just keep that in mind as we go through this. Okay, so unlike fractions. Unlike fractions are fractions that do not have the same denominator. Okay, they are not the same. Or you can put over here denominators not the same. Every time you are dealing with adding and subtracting fractions, you need to look at the denominators. You need to make sure that they're the same. Now, one way to be able to do this is to sit back and look at maybe a number line, and we think about 0 through 1, and halfway through 1 we have 1/2, and then the other is 1/4, and we put it together and we get 3/4. You can think of a dollar. If you have 2 quarters, that gives you half of a dollar. And if you have one more dollar, now you have 3/4 of a dollar. That's one way to look at this. Another way to look at this is the old method 2, and that's the way we're going to do right now. And it probably looked like this. This is something that maybe you had in 4th grade. It was more like this though. And we had 1/4. Maybe it looked something like that. Maybe it didn't. Okay. The idea here is that you are going to look at your denominators, and you'd say, okay, my LCD is 4. Lowest common denominator. Well, what can go? I know that because 2 can go into 4, and 4 can go into 4. So it's got to be my lowest because I didn't change this one. 2 can go into 4. I know it 2 times. That basically means I'm multiplying it by 2, and that means I'm multiplying this by 2. And so what does that mean up here? I get 2, and then this stays the same because I didn't do anything. And then I'm adding up the numerators. 2 plus 1 equals 3. And what do I get? I get 3/4. That's the paper way. It works the same way if you do it side by side, but it's the same thing. We're doing the same thing. Okay? Another way to do this is the cross multiplication way. There's different, there's another name for this. So I'm going to write this out. Let's say we have 1/2, and I'll see if you can guess the name. 1/2 times, sorry, not times, plus 1/4. And I'm going to write all this out. You're going to multiply basically 2 times 4. And then you're going to multiply 2 times 1. And then you're going to multiply 4 times 1. And so we're going to work all that out. So I'm going to set this up how this is going to look. A lot of times we're not going to write it all out. We're just going to actually multiply. But I'm going to write it out so that you can see. Don't forget we're going to, so 2 times 1 will go here. 4 times 1 will go here. And 2 times 4 will go here. I'm going to go ahead and start multiplying it all out. I'm going to put it down over here, or I'm going to bring it down a little bit. There we go. So you would have gone real quick on this. 4 times 1 we know it's 4. 2 times 1 we know is 2. 2 times 4 we know is 8. And then you would end up getting 4 plus 2, which would have been 6/8. And then you would have divided to simplify by 2. And you would have gotten 3/4. Now you might say, Mr. McCollum, all I did was change this to a 4 and I got 2/4 because 2/4 is half, and I added them up and I was able to get 3/4. Yeah, for this one, absolutely. We almost think about it this way. We could do this one in our head, yes. I probably wouldn't have needed to gone through method 2 or this new cross multiplying way. However, in the cross multiplying, what we end up getting is this is a great way to take care of what I call as negatives. And I don't have any negatives, so I got lucky. But if I have negatives, cross multiplying is a great way to go. Okay, there's your 3 methods. Now you try one. You can use LCD or cross multiply. Oh, and that other method was called the fish method, because when you're done, it kind of looks like a fish. Put a little eye there. Good luck. Okay, number 2 here. Well, we're going to utilize some items to be able to solve this one. I notice I have 2 of the same denominator when I look at number 2. So it's -3/4 plus 5/9 plus 7/4. And these 2 are in parentheses, and they want us to do these 2 first, but it's all adding. And because it's all adding, I know that I can move some items around. If it wasn't adding, I'd add the opposite, so I can move some items around. And the reason why I want to move items around, I want to switch these 2. And the reason why I want to switch these 2 is because these 2 have the same denominator, and if I can add those 2 up first, it's going to make life even easier. So let's go ahead and let's switch those around. So I'm going to have a -3/4, but instead of 5/9, I'm going to have 7/4, and then I'm going to have 5/9. Okay? So then we're keeping the parentheses in the same spot. So that means it's the commutative property. Of addition. That's why we like to have things in addition. That's why we add the opposite to get there. So this very first part, just like our lesson before, if you're not sure on how to do this, look up at the lesson before of like fractions and look to see how to do that, because our like fraction is 4, and so we get a -3 plus 7. And then when we're done with all that, we're just going to bring this all the way down, because don't forget we're going to add 5/9 to whatever we get here. Well, you got -3, 1, 2, 3. You got +7, 1, 2, 3, 4, 5, 6, 7. Okay, these three make zeros. I got positive 4 left over. I get 4 over 4. Let's change that around. I get this 4 over 4, which is equal to 1. 4 goes into 4 one time, and I'm going to add that 1 plus 5/9. And yes, you guessed it. If I'm going to add the 1 and 5/9, I'm going to get 1 and 5/9. So just by using the commutative property of addition, just by moving those, I was able to accomplish a lot. I didn't even have to deal with the numerators, because once I got to here, I got 1, and then 1 plus 5/9 is 1 and 5/9. In fact, I got rid of all of my negatives by doing some simple addition. Example 3. So this one, I see subtraction. Well, you probably guessed it. I don't care if you use the method 1. I don't care if you use the method 2, or if we're going to use what they the new one, which some people call the fish method. I think it's just cross multiplication. We're gonna add the opposite. Okay, that's probably the best way to do this. Add the opposite. So let's rewrite this. I'll even write it out. Add opposite. So let's write it all out. Negative 2/3 plus negative 1/2. Okay, yes, you can go through and you can set it up and get a common denominator of 6 and be able to get your answer. Okay, you can go through that whole process. Looks like we're multiplying 2/3 by 2 and 1/2 by 3. You still should add the opposite. You're able to get your answer, and then you have to reduce your answer. Okay, but what if we cross multiplied? 3 times 2. 3 times negative 1. 2 times negative 2. I'm going to write it all out so you can see it. This is what we call that fish method. The little dot meaning multiplying, or the eye of the fish. So let's check this out. Here we go. Here's my fraction bar. I'm going to write all of the multiplication that we're going to do. You're going to do that 3 times 2, so write it out. You're going to do 3 times the negative 1. Don't forget we're adding. We changed it to adding, so that really helps. 2 times the negative 2. So you make sure, so we're going 2 times the negative 2, 3 times the negative 1, and 3 times 2. You list it all out. Notice that I put the 3 times the negative 1, I'm going that way, that's why I put an arrow here. 2 times the negative 2, I'm going this way, that's why I put an arrow there. And then at the bottom is just the denominator. Okay, so same thing. Let's go ahead and draw my line and actually do the multiplication. 3 times 2, yes, you guessed it, was 6. 3 times negative 1, negative 3. 2 times the negative 2, negative 4. Well, I got lots of negatives. In fact, I got 4 and I got 3, which give me a total of negative 7 over 6. Okay, I want to show you something. I don't care if you've done this 1,000 times. It's negative 7 over 6. I want to show you something. Look at this. Negative 7 over 6. But all I did was multiply. And multiplying with integers is easy. That's why your 3rd and 4th grade teacher said learn your math facts, so that you can go through and we can do fractions easily, because all we're doing is multiplying. Now we're going to take our negative 7 over 6 and we're going to have to change it into a mixed number. Well, how am I going to do that? I'm going to take my 7, I'm going to divide it by 6. I know that it's negative, so I'm just going to deal with the division. It goes in one time. 1 times 6 is 6. I subtract, I get 1. I get a negative 1 and 1/6. There's my answer. If you're not sure on how to do this, you can go back to my like fractions, and I have another improper that I took care of, and I color coded it, the whole thing, so you can look back at that to be able to do that if you're having trouble with that. Well, your turn. Good luck. Oh boy, they put a word problem in there for us. All right. Okay, well, basically that's where fractions are. Okay, we use fractions in real life. We don't just throw 1/2 out there, or 3/4 or 5/8. Okay, they actually mean something. They have some meaning to it in life. Okay, that's a real world application. If you're not a math teacher, or, you know, most of the time you're not going to see arbitrary fractions that mean nothing when you grow up. Okay, but otherwise, when you go through life, you're going to see fractions, say, in cooking. You're going to see fractions in this case. Use the table to find the fraction of the total population that has type A and type B blood. Okay, so they call it a STEM, but basically this is science. Okay, everybody has a blood type. You either have O, A, B, or AB, and then nowadays they have like AB negative, AB positive, B negative, A positive, A negative, and so forth. O is neutral. They might even have another one now. So they've really defined what our blood types are. So if you go to give blood, that you have a particular blood type, and they put it with that blood. Okay, so it's that kind. And people that have certain blood types can only receive that type of blood if they need blood. So that's kind of how blood goes. You can't mix them, in a sense. And AB, you might say, well, wait a minute, isn't that mixed? Well, that's just the way. I believe you go back into science a little bit more. You can Google it and see if people who have AB can receive A and B blood, and so forth. And then you have O. Okay, well, they want to know. Use the table to find the fraction of the total population that has type A or type B. Okay, so they want to know the total. That's the key. So we're going to add them up. Why? Because it says total. So it's A and B. So basically what you're getting is you're getting 21/50ths for A, and you are getting 1/10 for B. Okay, some people are saying, you know, couldn't we just make this 10 a 50? Sure, why not? Do we have to do all of that multiplication? No. 10 times 5 will get me to 50. So 5 times 1 is 5. Pretty easy. 21 plus 50. Sorry, 21 over 50 plus 5/50ths. What does that mean? 21 plus 5 over 50 gives me 26 over 50. And then you're going to have to reduce. Okay, well, probably 2. It's always 2. Anytime it's even, it's always 2. 2 goes into 26, 13, sorry, not 13 times. Yeah, 13 times. That was right. 13. And 2 goes into 50, 25. That is reduced. I'm not going to be able to reduce that anymore. What does that mean? 13/25ths of the population has type A or type B blood. According to this, if you Google it, it's probably not right for this, but for right now we are using this as our info or our data to get our answer. Okay, that concludes our add and subtract unlike fractions. Remember, you could pause this video at any time. You can rewind this video at any time. You can look at this video at any time. You can redo the notes at any time, especially if you wanted to skip to a section. Once you've watched it and you wanted to skip to a section that you needed more help on, you can take a look at it and make it better. Okay, good luck.